So today we're going to be starting a new unit on quadratic equations. And so this is something that you studied in Algebra 1, but we're going to take it a little bit further here in Algebra 2. We are going to spend a little bit of time reviewing things. So today is just kind of let's remember what quadratic equations are, what the graphs of them look like, and how we can write a quadratic equation given 3 points. Now that'll be something new today. Let's go ahead and get started. So here's an example of why we would need like a quadratic equation. If, let's say we have Andrew Luck here, and he is throwing a pass, and we didn't have quadratic equations. We just had, let's say, a constant equation. It would look something like this. We would have y equals, let's say he releases the ball, I don't know, 6 feet high. And so if we just had a constant equation, his pass would just be 6 feet high forever. That would be the equation y equals 6. But we know that that's not what happens. When Andrew Luck throws a pass, he starts with the ball maybe going slightly up like this. But if that's all that happened, then it might be something like this. It might be an increase of so many feet per second. Let's say that it is every second the football would go up 20 feet per second, and so then it would be 20x plus 6. And so that's a linear equation. But we know it's not a linear equation because if that was all that it was, he would throw the ball up in the air, it would just keep going. The game would be over because the football would just continue to go up in the air. We'd lose the ball. We know that what happens is the ball starts up by going up in the air, and then eventually, because of gravity, comes back down. And so to describe that equation, we would have something like this: negative 16x squared plus 20x plus 6. The 6 gives you the initial height. The 20x gives you how fast it's going up in the air at the beginning. But then the negative 16x squared is the force of gravity that's pulling the ball back down to the earth. And so when we talk about quadratic equations, this is an example of a quadratic equation. And the negative 16x squared, that would be the force of gravity if we're talking about feet per second. So a quadratic equation in standard form, at least, there are different forms, but in standard form would look like this: ax squared plus bx plus c. And there are 3 terms here. The c is called the constant term. This would be a good thing for you to put in your notes. The b, we call that the linear term. That's what makes it linear. If I just stopped there, those are our linear equations. Y equals mx plus b, except we call the m a b, and it would be bx plus c. That would be a linear function. But now we are adding an ax squared. That is called a quadratic term. And so we have 3 different terms: quadratic, linear, and a constant term when we're talking about quadratic equations. Really, to be a quadratic function, though, all we really need is the quadratic term. But if we add a linear term and we add a constant term, it's still a quadratic function. So let's take these 2 functions and determine whether or not they are a linear or a quadratic function. So a lot of people would say that if it has an x squared, it's quadratic. If it doesn't, it's linear. And that's not always the case, because if that were the case, then the first function would be linear. There is no x squared there. But if we put this in standard form, which means we're going to have to FOIL this, we're going to take x times 3x, which is 3x squared, x times negative 1, which is negative x, negative 5 times 3x is negative 15x, and negative 5 times negative 1 is positive 5. And if I put all those things together, then my function is going to be 3x squared. Negative x and negative 15x is negative 16x plus 5. That's a plus there. I don't know what happened there, but so this would be a quadratic function. So number 1 is a quadratic function, and if I put it in standard form, it would look like this. Let's take a look at number 2. It looks like when you first look at it that number 2 is quadratic because there's not only 1x squared but there's 2x squareds. But if we put this in standard form, I'm going to start by distributing this 3. And so I'm going to have 3 times x squared is 3x squared. 3 times 2x is 6x. 3 times negative 3 is negative 9. And 3 times negative, and then we just have the negative 3x squared. But if I combine like terms, I will have a function 3x squared minus 3x squared, those cancel each other out, and then we just have the 6x minus 9. So even though this function looked like it was quadratic at the beginning, it's really not a quadratic function. It's a linear function because the quadratic terms cancel out. So part of what you're going to be doing on your homework is to determine whether or not a function is quadratic or linear. And in order to do that, you're going to have to simplify it, put it in standard form, and then determine whether or not it is quadratic like number 1 or if it's linear like number 2. Alright, so let's talk about the graphs of quadratic functions. If you graph a quadratic function, we'll get into this more in subsequent videos, but one thing that they're called parabolas, and you probably remember this from Algebra 1. Every parabola has an axis of symmetry. And we're going to talk about how to find that axis of symmetry, but basically it's where you would fold your paper or where you would fold it so one half of the parabola ends up on the other half. Then it has what we call the vertex. The vertex is this point at the very top. If it's at the top like it is here, it's a maximum value. And so if the parabola opens down, then the vertex is a maximum point because it gives us the y value that is at the highest level. If the parabola were to open up like this, then we would still have an axis of symmetry. We'd still have a vertex, but that vertex would be called the minimum point because that would be the y value that is at the minimum point of the function. So we're going to have parabolas, and the other thing that we're going to talk about today is how to write a quadratic function that passes through 3 points. We should be able to write an equation, a linear equation that goes through 2 points. But now we are going to be able to write a quadratic function that goes through 3 points, and this is how we would do this. We could start with our general equation, which is ax squared plus bx plus c, and instead of having the y equals on the left, I'm just going to put the y equals here on the right, and I'm going to then erase it over on this side. So what I'm going to do then is I'm going to take these 3 points and plug all 3 points in for my x's and y's. I need 3 values. I need the a, the b, and the c. And so if I take this first point where x is 2, I'm going to have a times x squared. Well, that's 2 squared. That's 4. So I'm going to call it 4a plus b times x. Well, that's b times 2. I'm going to call it 2b plus c equals the y value, which is 3. I'm going to do the same thing with the next 2 points. So if I do the same thing with this point, the x value is 3. So it's going to be a times 3 squared, which is 9. So that's 9a plus b times 3. Well, that's 3b plus c equals the y value, which is 13. And if I do the same thing with the last point over here, I'm going to have the x, which is 4. So it's a times 4 squared, which is 16. So I could write it as a times 16. I'm going to write it as 16a plus b times 4. Well, I'm going to write that as 4b plus c equals 29. So you see what we have here is a system of equations. And we could solve that system of equations really now 3 different ways. We can use substitution, we could use elimination, and we can use matrices. If we use substitution, it wouldn't be really too bad to eliminate the c values. And so we could eliminate the c values twice to make it an equation with 2 variables, and then eliminate either the a or the b, or we could use matrices. I'm going to go ahead and use matrices here, I'm going to go ahead and use substitution here. If this is equation 1 and equation 2 and equation 3, I'm going to start by taking equation 2 and subtracting equation 1. So in other words, 9a minus 4a is 5a, 3b minus 2b is 1b, c minus c is 0, they cancel each other out, and 13 minus 3, that's 10. So there's one equation with just a's and b's. Then I'm going to do the same thing with equation 3 and 2. I'm going to take equation 3 minus equation 2. So 16a minus 9a is 7a. 4b minus 3b is just 1b. The c's, c minus c cancels each other out. 29 minus 13 is 16. And so now I have two equations with two variables. And then if I call this equation 4 here and equation 5 here, then I am going to take equation 5 minus equation 4. So I'm going to have 7a minus 5a, which is 2a. b minus b is nothing. And 16 minus 10 is just 6. And if I divide by 2, a is 3. Then I'm going to plug 3 back into equation number 4 here. So 5 times a, well that's 5 times 3, which is 15, plus b equals 10. Well, that means that b, if I subtract 15 from both sides, b is negative 5. And if a is 3 and b is negative 5, let's go back to equation number 1. 4 times a, well that's 4 times 3, which is 12. 2 times b is 2 times negative 5, which is negative 10. Plus c equals 3. Well, 12 minus 10 is 2, plus c equals 3. And if I subtract 2 from both sides, that means c is 1. So my equation then that I'm looking for, I know it's in this form, but now I know what the a, the b, and the c are. And my equation is going to be y equals my ax squared, so that's 3x squared, plus bx, well that's minus 5x, plus c, which is plus 1. And so there we have our equation, 3x squared minus 5x plus 1. Here's what I'd like for you to do. If you're going to go through this, let's take a look at the similar problem, and I want you to pause the video and see if you can come up with what the equation would be here. So I want you to pause the video right now, and then you can start it once you're finished and see if you get the correct answer. Again, you would start with this equation, ax squared plus bx plus c equals y. And if you plug in all 3 points, if we plug in the first point, the x is 1, so it's going to be a times 1 squared, which is just a, plus b times 1, which is just b, plus c equals y. If you plug in the next equals, so I change that, it's a plus b plus c equals y, but y is 0. Then if I plug in the next point, x is 2, so it's going to be a times 2 squared, well that's 4a, plus b times 2, which is 2b, plus c equals the y value, which is negative 3. Then if I plug in the last point, x is 3, so it's a times 3 squared, which is a times 9, or 9a, plus b times 3, which is 3b, plus c equals the y value, which is negative 10. So here's our system. And now you can use matrices. If you use a coefficient matrix, it would look something like this. 1, 1, and 1, and then 4, 2, and 1, and then 9, 3, and 1. Multiply that times x, you'll get the answer matrix, which is 0, negative 3, and negative 10. And if this is a and this is b, you would just do the inverse of a times b on your calculator, and you would get that a is negative 2, b is 3, and c is negative 1. And so then your quadratic equation would look like this. That's what we're working today on the homework assignment, and we will go over this tomorrow when you come to class. We'll see you later.